Hello class, this is a video tutorial on the fourth example of related rates. So at any time you can pause the video. I'll just scroll through so you can see all of the questions. So here's the first page, and then here is the second. So let's get straight to it. A spherical balloon is being filled with water. Let's find an expression for the rate of change in volume over time. So let's consider that. What we are looking for is the rate of change in volume over time. Now let's think about what we've been given in the information. Well, from here we can see that it's a spherical balloon once again, so V is equal to 4/3 pi r cubed. From here we can find dV on dr, so the change in volume against the radius. This is going to be 4 pi r squared. As you can see, we can already use this. That is going to be dV on dr. If we were to multiply it dr over dt, we could cancel the dr's and leave us with what we are looking for. However, from the question we've been given, there is no such information. So I believe at this stage, all we can work with is leaving it at dV on dt equaling dV on dr is 4 pi r squared times dr on dt, which we will leave like so. So this is all we can work with. Okay, let's move on to the next question. Let's actually copy this because we're going to be needing it for the next part. So it says, assume that the water is flowing constantly at 50 centimeter cubed per second. I want you to think very carefully which of these rates that is referring to. Okay, so at what rate is the radius increasing when the radius is 7 centimeters? Now I want you to think again very carefully at what this refers to. Is that the change in volume over time, the change in the radius over time, or the change in the radius against the volume? Well, if you take a look, that is centimeter cubed. That there is volume. So in this particular question, we're being told that dV on dt is actually 50. So this is going to be 50. And it's asking for us now that the radius, what rate is the radius increasing? So we're actually trying to look for this value. So that is what we are looking for. So in this question, we're given dV on dt, and we're looking for dr on dt. So that's what we are looking for. So let's substitute what we have. It says 50 goes into dV on dt. We have 4 pi r squared times dr on dt. Well, part I is that the radius is going to be 7. So we're going to let r equal 7. So 50 equals 4 pi times 7 squared times dr on dt. This will give us 50 equals 28 pi dr on dt. And since we're looking for the change in the radius, we can simply find that by dividing by 28 pi. So dr on dt is 50 on 28 pi, which we can simplify into 25 on 14. 25 on 14 pi. That there is the rate at which the radius is increasing when the radius is 7. So let's actually use this again, this one here, because in part 2 we're again assuming that the rate of the volume against time is still 50, but now we're asking is what happens if the volume is 4,500 pi centimeter cubed. Oh, okay, so this is an extra bit of question here. Now, you have to really think about what this is saying. We're being told that the volume is equal to this. Well, right at the beginning, we had an equation for the volume, which was this. We're now being told that its volume is going to be 4,500 pi. From here, we can find what R is. So let's solve for that. We can divide both sides by pi. 4,500 divided by 4 is going to be 1125 equals 1/3 R cubed, timesing both sides by 3 equals R cubed, taking the cube root of both sides, so the cube root of 3375, using my calculator here, is equal to 15. So this question can be really reworded as what rate is the radius increasing when the radius is 15? We weren't being told that, but we are only being told what the volume was. So this now becomes similar to this question, which is why I'm going to just copy this. And instead of 7, we're going to substitute 15. So we get now 50 equals 4 times 15 squared. That's going to be 900 pi dr on dt. To find the rate of change in the radius, we just divide by 900 pi. So dr on dt is, I'm just going to do that actually, 50 divided by 900 is 1 on 18 pi. So the rate of change that the radius is increasing by when the radius is 15 is 1 on 18 pi. Okay, so that is part B. Notice very carefully, and you should be reading very carefully the question, that this here is referring to the change in volume against time. Let's move on to the next question. Now it says, instead assume the water flow adjusts such that the radius increases at a constant 2 centimeters per second. So in this question, the volume was always 50 centimeter cubed. In this question, the water flow adjusts, but the radius increases at a rate of 2 centimeters per second. So I want you to really think about what this part is referring to. Since the radius is increasing, that is a rate, that is dr on dt equals 2. So now, let's grab this, sorry, my apologies. Let's grab this expression here. So we're now going to initially use part A, but in this particular question, we're being told what dr on dt is now, which is going to be 2. Okay, so we can find dv over dt, because remember initially, right at the beginning, we had dv on dt equals dv on dr equals times dr on dt. We couldn't solve for this because we weren't given dr and dt. But in this particular part of the question, we're now being told that it's going to be equal to 2. So, using this particular piece of information, we can now substitute that here. So, dv on dt is 8 pi r squared. That there is dv on dt. So, lastly, it now says when the flow rate is 100 centimeter cubed per second, think very carefully what that is referring to. What is the balloon's radius? So in this question, we're looking for r is equal to something, but the flow rate being given, that is actually going to be dv on dt. That is volume per second. Volume over time. So we're being told that dv on dt is 100. So now we can solve this. So 8 pi r squared is equal to 100. I'm substituting 100 here. Now solving for r squared equals 100 over 8 is going to be 100 over 8 is going to be 25 on 2. And since we divided by pi, there's going to be pi in the denominator. Taking the square root of both sides, it's going to be 5 on 2 pi, but the denominator is going to be underneath a square root. So that there is the radius of the balloon when the flow rate is 100 centimeter cubed per second. So I hope that gave you an insight into the various ways in which the questions can be changed and asked, but hopefully you're beginning to see the language in each of the questions and what it refers to in the actual algebra itself. Hope to see you in the next video where we do the final example. Hope to see you then. Best of luck.